In this video, I will explain how the event loop in JavaScript works in simple terms and with clear examples. This is one of the most common interview questions. What is the event loop and how does it work? If you haven't fully grasped its principles yet, everything will become clear after watching this video. For a clear explanation, we will use this event loop model. Let's take a closer look at it. So, in our example, we have code consisting of synchronous code, lines 1 and 15, one macrotask, line 3, two microtasks, lines 7 and 11. The macrotask is represented by a large red ball. The microtasks are shown as two smaller green balls, and the synchronous code is represented by white cubes. The code executes in the main program thread, line by line from top to bottom. All tasks go into the call stack. From there, they are either sent to the web API or immediately output the result to the user's screen. Tasks that return after being processed by the web API go into queues. Microtasks go into the microtask queue. Macrotasks go into the task queue. When the call stack is empty, the event loop comes into play. In our model, it is represented as a yellow egg-shaped mechanism. First, it opens the microtask queue, allowing all tasks from it to enter the call stack one by one, executing them all in sequence. Only after all microtasks have been completed does the event loop move to the task queue, allowing one macrotask to enter the call stack per cycle. So, it's time to explain how the event loop works in JavaScript using our simple example, and we'll do it in 100 seconds. Let's go. First, the synchronous code executes. Console.log start from the first line enters the call stack, and we see the message start on the screen. Next, we encounter a setTimeout call with 0 delay on the third line. Even though the delay is 0, this call does not execute immediately. Instead, it is scheduled as a macrotask and sent to the web API, whose job is to track the timeout. Once processed by the web API, the macrotask moves to the task queue, where it waits to be executed. Then, two microtasks are created, one via promise.then, another via queue_microtask. After being processed in the web API, both are placed into the microtask queue. Once all asynchronous operations are scheduled, the synchronous code continues executing and we see the message end on the screen. At this point, the call stack is empty, so the event loop takes over. It first processes the microtask queue. It logs promise, microtask, and queue_microtask. Only after all microtasks have been executed does the event loop move to the task queue, where setTimeout fires and logs setTimeout macrotask. This is how the event loop controls execution order. Synchronous code first, microtasks next, macrotasks last. Now you definitely understand how the event loop works in JavaScript, just in case you're asked about it in an interview. Next in our video, we will take a detailed look at all the important aspects of how the event loop works, including what microtasks and macrotasks are, the role of the web API in this process, what it means that macrotasks are processed by the event loop one per cycle. Stay tuned. By the way, you can play around with this interactive event loop model and test your knowledge with a quiz on our website. You'll find the link in the description below the video. Let's move on. In JavaScript, there is the concept of tasks, operations that do not execute immediately, but are scheduled by the engine in a queue. Tasks are generally divided into macrotasks and microtasks. Macrotasks include setTimeout, setInterval, tasks scheduled with timers, I/O operations, handling input-output events such as mouse clicks, keyboard events, etc. setImmediateNode.js, similar to setTimeout, but specific to Node.js. Request animation frame browsers, used for rendering and animation-related tasks. Microtasks include promise callbacks, handlers passed to .then, .catch, .finally. queue_microtask explicitly adds a function to the microtask queue. Mutation observer callbacks, functions used to detect DOM changes. Process.nextTick, Node.js, executes before other microtasks even though it technically doesn't belong to the standard microtask queue. JavaScript is a single-threaded language, which in our model is clearly represented as a single pipe, the call stack of limited width. If a task that takes a long time to execute enters the call stack, it will block the pipe, preventing other operations from running. In simple terms, the program will freeze and become unresponsive to user actions. To prevent such situations, the event loop works together with the web API. the Web API takes Microtasks and Macrotasks for processing, freeing up the call stack. This ensures that JavaScript code does not get stuck on long-running operations. Once tasks are processed, the Web API returns them with results to their respective queues. Microtasks go to the Microtask queue. Macrotasks go to the task queue. The event loop then checks if the call stack is empty. If it is, all Microtasks from the Microtask queue are executed first. One Macrotask from the task queue is executed per cycle. On the next cycle, the process repeats, keeping JavaScript efficient and responsive. Let's modify our code. We'll remove Microtasks from the main flow. Instead, we'll place a Microtask inside a Macrotask, a scenario known as task within a task. This will demonstrate how the event loop processes only one Macrotask per cycle. You can pause the video and try to predict the output yourself. Now, let's continue. Watch carefully. The synchronous code runs first, so we see start. 2 Macrotasks, set timeout, are scheduled. They are sent to the Web API and later moved to the task queue. The last synchronous line executes and we see end. Since the call stack is now empty, the event loop begins. It first checks the Microtask queue, but it's empty. It moves to the task queue and allows only one Macrotask into the call stack. The first set timeout. The first Macrotask executes. Macrotask 1. Inside this Macrotask, we call promise.resolve.then, which schedules a Microtask. This Microtask is sent to the Web API and later moves to the Microtask queue. The call stack is now empty, so the event loop starts again. First, it checks the Microtask queue. Now there is a Microtask waiting, so we see Microtask. Then it moves to the task queue and processes the second Macrotask. We see set timeout, Macrotask. Compare this with your prediction. If you got it right, congratulations. If not, don't worry, keep practicing. In the description of this video, you'll find a link to our website where you can explore the interactive model, the same one we're showing in the video. There, you can sharpen your event loop skills by experimenting with different scenarios. Try it out and see how JavaScript's execution model works in action. That's all we wanted to share about the event loop in JavaScript. We hope you now have a better understanding of how tasks are scheduled and executed in a single-threaded environment. If you still have questions, feel free to ask in the comments. Subscribe to the channel because in our next videos, we'll be covering how the Web API works, dynamic memory, heap, event loop in Node.js, and much more, explained in a simple and clear way. Like the video, leave a comment. It really helps the video reach more people. And don't forget to share it with your friends. Let's reinforce what we've learned. Synchronous code executes first. A Macrotask is scheduled. 2 Microtasks are scheduled. Synchronous code finishes executing. The event loop kicks in. It first processes all Microtasks in the Microtask queue. Then it takes one Macrotask from the task queue and executes it. This structured execution order ensures that JavaScript remains efficient and responsive.